Hey everyone, welcome back to the Workplace Apprenticeship 20 videos. In this video, we're going to look at lesson 1 from chapter 4, which is talking about solving for angles, lengths, and distances. So in order to solve problems that involve right triangles, we can use a few different methods depending on what type of information we're given and what we're actually looking for. So one method that we can use to solve right triangles is using the trigonometric ratios. That's typically when you're either looking for an angle or if you're given an angle and need to find a side. So there's 3 different ratios that we can use, and that is sine, cosine, and tangent. And depending on what information you're given will depend on which ratio you're using. So if you want to use sine, you will have your opposite hypotenuse. For cosine, it's adjacent and hypotenuse, while tangent is opposite and adjacent. And in terms of your triangles, your hypotenuse is always across from your 90-degree angle, so it's your longest side. The adjacent is the side that creates that angle with the hypotenuse, and then the opposite side is opposite your angle. So it does not create, it's not one of those sides that creates that angle. So there's a little jingle here that'll help us figure out or help us remember which sides belong to which ratio, and that's called SOHCAHTOA. So means sine is equal to opposite over adjacent, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So the next method that we can look at is using the Pythagorean theorem. And according to the Pythagorean theorem, that says that your side A squared plus your side B squared is equal to your side C squared. Now, one thing that's really important here is that A and B, it really doesn't matter which side of which side you're dealing with. The one that's really important though is the C value. This one here has to be your hypotenuse. So A and B, doesn't matter which leg you're using. The one that's really important is that hypotenuse has to be C. So this has to go as a little standalone value here. Okay. So now we're going to practice using the Pythagorean theorem and the trigonometric ratios, and we're going to do example number 1 from your notes. So Ethan buys a used portable conveyor for stockpiling landscaping materials such as gravel in his maintenance yard. The conveyor has a length along the belt of 12 meters and makes a maximum angle of 15 degrees with the ground. So part A is asking, what is the maximum height of the gravel stockpile that this conveyor can make? So here we're looking for the maximum height of this gravel stockpile that the conveyor can make. So that's when we're talking about going from the ground all the way up to the top of our conveyor belt. So we're looking for this H value here. So one thing that when we're talking about the height, your height goes straight up and down. So it's what we call perpendicular to your ground. So this actually creates a right angle here. And so this overall picture here is a right triangle. So when we're trying to find the maximum height, we need to look at what kind of information are we given. So we know that we have 15 degrees here. So we're dealing with angles. So that means that we are going to be using one of those trigonometric ratios. If you guys remember, when you're dealing with sides, if all three bits of information that you're given or looking for are all sides, then you use Pythagorean theorem. But as soon as you're given an angle, you're going to be using the trigonometric ratios. So whenever I'm dealing with these types of problems, sometimes it's a little bit easier if you redraw this problem, looking a little bit simpler. So what I'm going to do is I'm just going to remove that picture of that conveyor belt. So we're really only going to be looking at a picture of a right triangle here. So here we know that we have an angle of 15 degrees, and then the length of that conveyor belt was 12 meters. And then we're trying to find that height going up to the top of that conveyor belt. So I'm going to leave that as H. So here you're given your angle. We have the side that is opposite of the angle. So here would be your opposite. And then we're given the side across from that 90-degree angle, which makes that the hypotenuse. So here we have an angle, the opposite side, and your hypotenuse, which means that we are going to be dealing with the sine ratio. And if this helps you, write this out. Write SOHCAHTOA on the side. And then ask yourself which one has an O and an H. And you see OH right here, which means that we're dealing with the sine ratio. So I always start off by writing my ratio. So we have sine of, say, an angle theta, and that's equal to your opposite over your hypotenuse. Then what we're going to do is we're going to fill in the information that we know. So we know the angle here, theta, is 15 degrees. So we're going to write sine of 15 degrees, and that's equal to your opposite. You don't know that. You can just leave that as h for your height. And then your hypotenuse was 12 meters. And just for simplicity's sake, we're not going to write the units in. We'll just write 12. So what your next step should be, either you can treat this like an equation where you would want to solve for h, or one thing that would be nice to relate this back to our chapter 1 is that if we write this over 1, we have two proportions equal to one another, so all we have to do is cross multiply and solve. So you cross multiply, so the denominator of one fraction multiplies with the numerator of the other fraction. And so what we get is sine of 15 degrees times 12. And I'm going to write this as 12 times the sine of 15 degrees. And I do that just because I don't want my 12 to be on the right side, or I might confuse that as being part of your angle. So you have 12 sine of 15 degrees is equal to 1 times your height, which is just h. So then at this point here, we have h by itself. We have all the other numbers on your left side, so we can put this into our calculator. One thing that's really important here is make sure your calculator is in degrees. And to check if your calculator is in degrees, most of them will have a capital D or capital letters DEG. One of those symbols will represent degrees. If you have something that's, say, a G or an R, then you need to switch it because this is gradients and radians, and that's going to affect your answer. You're not going to get the right value because that's radians and gradients are different types of units from degrees, so you have to make sure you're being careful with your calculator. So before you do any calculations, make sure it's in degrees. If you guys have any questions about how to change your calculator into degrees, just come see me in class or just text me on Remind 101, and I'll try and give you as much help as I can, at least over text message on Remind. So anyways, so hopefully you've had a chance now to put this into your calculator, and what we should find is that 12 times the sine of 15 degrees is 3.11, and our units here are meters. So go to 2 decimals and don't forget your units. So that means that the height of that conveyor belt is 3.11 meters, and so that is the maximum height of that gravel stockpile. So then just to finish off this part A question here, we just need to answer this using a sentence. So we could say the maximum height of the pile can be 3.11 meters. And as soon as you've done that, written your sentence, we're ready to move on to part B. So part B says, the gravel stockpile is in the shape of a cone and makes a 37-degree angle with the ground. The volume of the material, what volume of the material can Ethan store in the stockpile? So this one here actually relates back to chapter 3. So here we're looking at what volume of material can Ethan store in the stockpile. So here we're looking at a cone. So in order to find the volume of your cone, we need to know some certain bits of your information. So first I'm just going to start off by writing your formula. So your volume is equal to 1 over 3 times pi times r squared times your height, or h value. So some of the things that we need to know in order to calculate your volume is we need to know your radius, and we need to know the height if we don't have that. So you need your height going from the top of that cone, going down to the middle, and then we also need to know our radius. So r is our radius, h is your height. Now, when we're talking about the gravel stockpile, and we're talking about that height, well, we calculated that in part A, so we can replace our H value here with the height that we found in part A, which was 3.11 meters. Now, we do need to calculate your radius though, because we don't know what the diameter is, we're not given any radius. All we know is the angle that's created is a 37-degree angle with the ground. So if you started from here on the ground and then be going upwards, so right here would be a 37-degree angle. So step number 1 is to calculate or find your radius. And in order to find your radius, we can look at even just a little snapshot of this cone. And if you notice, our height here with the ground is going to create that 90-degree angle. So once again, we have a right triangle. So this is just taking a little snapshot of that cone. So our radius here is r. Our height is 3.11 meters. And we know what this angle here is 37 degrees. So here we have an angle. So we're going to be using one of those trigonometric ratios. So here we have the side that is connected to your angle but is not the hypotenuse. So that is your adjacent. And then we have the side opposite of your angle, which is your opposite side. So here we have your adjacent and your opposite, sorry. So looking up at SOHCAHTOA, which one has an O and an A? Well, that one here is your tangent ratio. So we're going to use tangent to find our radius. So we'll start with tan of theta is equal to your opposite over your adjacent. And then you're going to fill in those values. So you have tan of 37 degrees is equal to, so your opposite is 3.11. And you don't know your adjacent, so you're going to leave that as r. Once again, we're going to put tan of 37 over 1, and then we're going to cross multiply. So what we get is r times tan of 37 degrees, and that's equal to 1 times 3.11, which is just 3.11. Then we want to get r by itself, and here it's multiplying with the tan of 37 degrees. So to get rid of multiplying, you're going to divide by tan of 37 on each side. So this will cancel out. You're left with just r on your left side. And if you were to put this into your calculator, 3.11 divided by the tan of 37 degrees, we should find that that radius there is equal to 4.13 meters. So now that we have our radius, now we can go ahead and find the volume. So to find your volume, you're just going to use this equation here. So you have your volume is equal to 1 over 3 times pi times your radius squared times your height. So your volume is equal to 1 over 3 times pi times your radius, which is 4.13, and we'll square that. And then multiply that with your height, which was 3.11. And then you can put all of this into your calculator. I would caution you, though, just because depending on what type of calculator you have, you might need to make sure you put brackets around this 4.13 squared. Or else your calculator might try to square 1/3 times pi times 4.13. So if you put all that into your calculator, we should find that your volume would be 55.55 meters cubed. So now that we've found the volume of our pile, we've answered this question. But just to make sure we properly answer this question, we need to make sure we have a sentence, because this is a word problem. So you could say the volume of the stockpile is 55.55 meters cubed. So don't forget your units there. Your units are meters cubed.